Ooh, ooh, ooh. So if we take a look at Le Chatelier's principle, and I just want to confirm that's still running, yes. Okay. Take a look at Le Chatelier's principle. Le Chatelier's principle is our main guiding principle for working out chemical equilibrium. Okay, and what it says in your exam guidelines is when the equilibrium of a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that opposes the disturbance. Okay, so what that's saying is that when we disturb a chemical reaction that is already in equilibrium, okay, this only applies when it's starting from equilibrium, then the system will do something, and we'll discuss what that is now, that will balance that out and cancel it out and try and push back in the other direction. Okay, so for example, if you try and heat up a reaction, the system will do something to try and use up that heat, to get rid of the heat, to cool things down again. And you always get these reversing opposite things happening, right? To understand the Chatelier's principle a bit better, let's remember the 6 factors that affect rate of reaction. You've got concentration, temperature, pressure, surface area, nature of reactant, catalyst. Of these 6, only these 3 over here, concentration, temperature, and pressure, will affect the chemical equilibrium. These other 3 over here, they're going to change the rate of reaction, but they're going to change the rate of reaction just as much for the forward reaction as they do for the reverse reaction. So there's no real change to the equilibrium from them. Okay? So for example, catalyst. A catalyst will speed up the forward reaction, and it'll speed up the reverse reaction. So the equilibrium stays. The nature of reactant, you've got basically the same reactant, whether it's the reactant or the product, and that doesn't really change that. Surface area also. If you've got a large surface area of reactant, that'll end up giving you a large surface area of product, so the reverse reaction will also be quicker. Small surface area of reactant will tend to give you a small surface area of product, so the reverse is going to basically match and be in equilibrium with the forward. Okay? But concentration, temperature, pressure, we'll go into these 3 in a lot more detail one at a time and discuss exactly how they affect chemical equilibrium. But those are the 3 ones to remember. Those are the 3 ones to focus on. Okay. Then we've also got a general way of remembering how the Chatelier's principle affects the products that you're going to form. How does it actually end up giving you something different from what you had before? And I remember it as the little French rebel, okay? Because Le Chatelier is a French guy. He's a rebel because he's always trying to do the opposite. And you just have to remember that he's little, okay? So D is for disturbance, right? You state what is the disturbance to the system in equilibrium, okay? Are you changing its concentration? Are you changing its temperature? Are you changing its pressure? Are you increasing or decreasing? Increasing or decreasing, increasing or decreasing, right? So there's always 6 possible ways that you could disturb the chemical equilibrium. Tell the examiner which one of those 6 it is. Also tell yourself, right? Because this D step over here affects everything else that comes after it, right? So always start by being very clear about what the disturbance is. And there are only 6 possibilities, right? Increase or decrease of those 3 factors. Then, step L. State how Le Chatelier's principle will apply when you make that disturbance. So this flows from the previous step. And we said Le Chatelier always wants to do the opposite of what was done to the system. Okay, so if you increase the temperature, Le Chatelier will want to decrease the temperature. If you decrease the pressure, Le Chatelier will want to try and find a way, or the system rather, will want to try and find a way to decrease the pressure. Did I have that right around? What did we do? We decrease the pressure, so Le Chatelier wants to increase the pressure. Okay. So really what you're doing with these 2 steps is pretty straightforward. Say what change we made, and basically say the opposite of that, because that's what the system will try to do according to Le Chatelier's principle. Okay. Then step F, state the forward reaction direction, the forward reaction or the reverse reaction. Which one of those is going to give us what Le Chatelier wants? Okay, so we go from this step to this step to this step. They're all flowing from one to the other very nicely. Okay, how we pick the favored direction, that will depend which of these 3 factors we're looking at, And when we go into each of these three in more detail, then you'll know how to pick this one. But that's basically a result of what you want in the second step here. So it has to connect, okay? And then finally, step R, what will the result of this be? Okay, will you get more product or less product? If you're favoring the forward reaction, you should get more product. If you're favoring the reverse direction, less product. Okay, and that's quite useful and quite important if you are actually trying to make something. If you're a factory that makes, oh, I don't know, nylon, okay, and you do your chemical reaction for producing nylon, do you want your reaction system to favor the forward reaction or the reverse reaction? If nylon, the product, is a product of the forward reaction, well, clearly there you want the forward reaction favored as much as possible. And we've got a nice sort of mathematical way of looking at that as well, which we'll do later on as well, called the equilibrium constant. An equilibrium constant is trying to spot exactly that. Is, are we making more of the reactant we started with, or more of the product that we're trying to get to? Okay, but that's for later, right? So that's your introduction to Le Chatelier's principle.